Hello and welcome to the lesson 6 in the chapter 3. This is about derivatives of trigonometric functions. We will recall our friends sine, cos and tan. And for this lesson, it is very important to remember the previous lessons, the power rule, the product and the quotient rule, and the chain rule. So all those three will be employed in this lesson when we derive trigonometric functions. Now we will look into the learning objectives. They are to find the derivatives of trigonometric functions using differentiation rules. That is all the rules which we studied in the previous lessons. And then to solve physical and engineering problems using derivatives of trigonometric functions. Basically real world problems. Now, lemmas means rules, or what is something that's already proven, okay? These are few of the things which we had seen in the limits lesson, that's chapter 2. If the theta is tending towards 0, sine theta is equal to 0. And what about cos theta? It's equal to 1. We know this. You can even try it in the calculator. You'll get these answers. And over here, if sine theta divided by theta, if theta is tending towards 0, then it is 1. We have proved this in the chapter 2. And over here, 1 minus cos theta by theta equals 0. So these are few things. These are lemmas in the sense we have already proven this, or these are rules, like standard rules. Now using these, we have derived the theorems, these three theorems. For you, if you just know these theorems, the rules, they are more than enough. That is, the derivative of sine is cos, the derivative of cos is sine, and the derivative of tan is secant square x. Always remember, if the derivative is starting with c, cos, cot, cosecant, then there will be a minus sign. So always remember, if the derivative of any c type of functions, in the sense cosecant, cotangent or cosine, we have to have a negative sign with the answer. Whereas if it is, just the other functions, sine, tan and secant, you don't need to use d by dx. Don't need to have the minus sign. It's always positive. So derivative of sine is cos, derivative of cos is negative sine, and derivative of tan is secant square x. Now then, we will try to solve trigonometric problems. Here the first problem, if you recall, this is two separate functions. How do we solve this? If you have remembered it rightly, it's from product rule. So let me understand, this is a u function, this is v, and I know the rule is u dash v plus uv dash. What I do is the first function, let us derive it. I'll do it quickly because by now you must be thorough with these, okay? It is phi x to the power 4 multiplied with cos x plus, what is u? Phi x to the power 5 as it is, multiplied with minus sine x. That's it. You can rearrange and write this as phi x to the power 4 cos x plus x power 5. Okay, sorry, I meant to write minus. This is sine x, but the thing is it'll become minus, so I'll just erase this plus to everything went. It's just minus here, okay? Why? Because this minus sign is multiplied outside. This would be the answer. Very straightforward. Apply the product rule and simplify as much as you can. See, the product rule over here, I'll just erase this for a while, is f dash x g of x, that's the second function as it is, plus f of x g dash of x. Now all you do is derive the first term, second term as it is, plus the first term as it is, derive the second term, and then we get phi x to the power 4 cos x minus x power 5 sine x. That's it. That's what we call. Now how do you solve this one? Okay, this is a bit important. Why? Because look at this. We have sine square x. So whenever the square is given to the, say the square is to the sine, it means it's for the sine function. What happens is sine x, right? The whole square, we use it as a whole square. Always remember this. When it is sine square x, the square is not to x, it's for the entire function. Now how do you derive this? It's by the power rule. 2 comes down, it will be sine x power 1. But don't forget, this is a chain rule. You solve the power rule to sine x. Power 1, we don't write it. It's 1 as it is. Now remember, multiply it with cos x. Why? Because the derivative of power rule is done, and whatever is inside, that's the outer function derivative. Power rule. Sorry, power is outside function. What is inside sine x? Derivative is cos x. That is the inner function. So it will be 2 sine x cos x. This would be the answer. So that's it. So always remember, it's the outer function, then derive the inner function. It will be 2 sine x cos x. Okay. Very simple and straightforward. Now what about this one? Again, now what I would ask you is to pause the video and solve this by yourselves, because this is again another straightforward problem. Please do pause the video and try it. I hope you tried this. So let's solve it up together now. So this doesn't have any product rule or quotient rule or chain rule. It's a very, very simple problem. There are just the constants, right? These are the constants. So what we do is basically write them. 4 will remain as it is. What about tan? Derivative of tan is secant square x minus, this is done, nothing else. Okay, that's a single function. Now there is phi. Cosecant derivative is cosecant into cot. Okay, cosecant x into cot x. That's it. That will be the answer. It's very, very straightforward. Let's just check the answer. It's 4 secant square x. Now there's an important mistake which I did over here. Always when derivatives functions start with c, you're supposed to have a minus sign. The derivative of cosecant, let me just write it over here. Cosecant, CSC, is, derivative is cosecant, write it as it is, x cot, sorry, it is all with c, but there is a minus sign. That is the important thing. There will be minus sign, so there will be 2 minus sign, it becomes plus. Okay, this will have a minus sign. Whereas for secant, it will be secant into tan. It's very easy to remember these formulas. So that's why it's plus. Okay, because they dissolve. Minus minus becomes plus. That's it. Now these are very interesting. Now first thing over here, look at the first one. It's cos x cube. Next one is just cos cube x. And last one we have cos 3x. All about cosine. When you derive cosine, it's minus sine x. But now look at the powers. That's the problem, right? How do we solve this? 3 cases. Let's solve one by one. You will see the difference. Now the first case over here. Sorry. Let me just change this. The first case here, you can see it's cube. But where is the cube? This is also having a cube. This is to the cos. If it's for the trigonometric function, remember to put the brackets and then outside will be the cube. Whereas this cube is only for the x. So you have to put x cube and then bracket. That's the difference. Over here there is nothing. Just write it as it is. Okay, now we will solve over here. So over here, the outer function, this is the inner function. The outer function is cos. Solve it, chain rule over here. It will be minus sine x is x cube over here, multiplied with the derivative of the inner function, that will be 3x squared. That's it, that's the answer. What about this over here? Cos x cube, this cube, the power 3 is the outer function. So 3 comes down, it will be cos x whole square. Now multiply by the inner function, that would be minus sine x. That's it. Here outer function is cos, this is the inner function, so it will be just minus sine x is 3x multiplied with derivative of 3x is 3. So this is how basically we solve it. Look over here. First understand which is inner and outer. Outer is cos, so it becomes minus sine. Whatever is there, write it as it is. Then what is the inner function? You derive it. Here the outer function is power 3, so 3 comes down, cos x squared, multiply with the derivative of cos x is minus sine x. Here we have cos 3x, so what happens is it becomes minus sine 3x times 3. Why? Because cos derivative is minus sine, and we instead of x we have 3x, so we write that derivative of 3x is 3. These are the answers. You can see over here, that's the first answer. Now here what you can do is you can write it, rearrange it, write this term first and then sine. However, that's the same answer, no much difference. Now, one more thing, you can remove this bracket off. You don't need to write x cube bracket. Over here you can write this. You should know that whenever x cube is written, the bracket is only for x cube. X cube will be the inner function. What about this? That's the answer. Now it's just written 3 minus 3 sine x cos square x. Here, remember, see this cos x bracket square, this can be written over here. Instead of, the bracket, you can just write cos square x. Cos square x and cos x the whole square with the brackets is the same thing. See, this and this is same. Lastly, we have over here minus 3 sine 3x. That's the answers. So this is how we basically solve this problem. Very straightforward ones. Now we find the derivative of this problem. Here, while looking at it, I can see there is x in the top, x in the bottom, so there is quotient rule. But sine is out. So which is the outer function? Outer function is here sine. So I'll write cos. What is the inner function? 2x by x plus 1 as it is. Now derive this term. It will be d by dx, derivation of 2x by x plus 1. But remember, when we derive this, it's u by v rule. That is u dash v minus uv dash divided by v square. Now this remains as it is. Cos 2x divided by x plus 1 is the same thing. What about this right side? Right side derivative would be, upper term derivative would be 2 multiplied with the below term x plus 1 minus upper term as it is, derive the bottom term, that would be 1 over here, because x plus 1, x is 1 plus 0, it's basically 1, divided by the below term square, it's x plus 1 the whole square. Now you can just simplify this. You can multiply 2x inside, plus 2 minus 2x divided by x plus 1 the whole square, minus 2x and 2x cancels. So here the left side, this term remains. Okay, I'll just write it over here. The same thing must be written here as well. 2x by x plus 1 multiplied by 2 divided by x plus 1 the whole square. This is the final answer. You can see it would be cos 2x by x plus 1 multiplied by 2 by x plus 1 the whole square. That's it. Very easy, very straightforward, one by one. See over here, all the steps are not there, but you can see this. You can pause it over here now. All the steps are there, the quotient rule steps. We have done this in the previous lessons. Now we will see an equation problem, the lesson 3.1, the first lesson. We had many of these. Now since the x value is given, remember you can use the calculator over here. You can easily solve the slope by calculator, and then we must use the equation of the tangent line. I'll write the equation of the tangent line. Y would be equal to m tangent into x minus x naught plus y naught. Okay, I was just blanked out for a while. I can't believe, because I've used this so many times in my classes in the school, and I just went blank. But anyways, this is the formula. Here the slope of the tangent is by the derivative of this equation and apply the x value over here. But this we have done it previously in previous videos, but I'll do the calculator method now to save time. And what about this x naught? Whatever is given is basically x naught here. How do you find y naught? Here, instead of y, to find y naught, you must just put the x value wherever there is x naught value, sorry. It's pi by 3 minus 2. Cosecant cannot be put in calculator directly. I'm sure most of us wouldn't remember what is cosecant pi by 3. So you can just use 1 by sine. 1 by sine is cosecant, x is pi by 3. So this is how you can usually use the calculator. This 2 will come up, or you can write 2 multiplied by 1 by sine x, because cosecant x is 1 by sine x. Okay, CSC x is equal to 1 by sine x. That is the reciprocal rule. Now if you put this in calculator, you will get the answer of y naught, and then you know x naught. All you need is m tangent. Let us use calculator to solve it now. Here then, first let me do the derivative. Let me just clear the calculator. Okay, now since we have pi by 3 and everything, I'll change this mode to radian. That's by shift mode and 4. Now it's in radian. Now to solve this derivative, it is shift and dy by dx. Okay, that's the derivative of this function. 3 tan x alpha x, close the bracket, minus 2. You don't have cosecant, so what do we have to use? Divided by sine alpha x. Okay, close the bracket. Or you can write 2 multiplied by 1 by sine x. It's the same thing. Now x is how much? At pi by 3. So over here there is shift and pi divided by 3. Just press equal to. The answer is 40 by 3 or 13.33. Okay. So let's just quickly check the answer. Yes, it's 40 by 3. So you can directly get the answer 40 by 3. Now all you do is substitute everything back into this equation. See, this final answer is basically 40 by 3 into x minus x naught plus this is what? This is the y naught value. How do you do in such a way? I'll tell you now. Let's go back over here. See, why? Because if you put this directly in the calculator, you'll get an answer, solved answer. But the most of the time, the options will not be just solved. It will be like this. So I will show you now how to do that. I hope this much is clear. M tangent we solved out just now in calculator. X minus x naught is always given. Now plus y naught. This entire term is y naught. We will see now here. I'll write this y. Let me just use this. Y equals m tangent was 40 by 3. We solved in the calculator. X minus x naught is pi by 3 plus. Now what is y naught? Let's take the calculator back. Here we got m tangent, right? Same way, put this value now. 3 tan pi by 3. It's already in radian mode, so it's fine. What's the answer? 3 root 3. Now that is the first part only. Now what's the second part? Just put that as well. It is 2. I can just write 2 multiplied by. I'll write that because 2 multiplied by cosecant is 1 by sine pi by 3. Close the bracket. What's the answer? 4 root 3 by 3. So all we need to do is write it out over here. Here it is. We got 3 root 3 for the 3 tan pi by 3, 3 root 3. Now here it's minus 2, sorry, minus 4 root 3 by 3. So this is the final answer. This is what we get over here. Okay, now, okay, if you're thinking why it's not like this, over here it's 5 root 3, over here it's a root 3 by 3, because these both values are the same. I will simplify it. Now, how do you simplify that is, now only this part I will simplify. Okay, I'll write over here 4 root 3 by 3. Sorry, it's 3. Let me just write like this. 4 root 3 by 3. Now, what is 3 basically? 3 is root 3 times root 3, isn't it? Why, if you multiply square root of the same term 2 times, it's basically the square roots cancel. The 3 can be written as root 3 times root 3. If you put in calculator, you'll get 3. I have 4 root 3. Now, this root 3 cancels with this. What is remaining? 4 by root 3. So this is how we can easily, whenever we see such cases, root 3 by root 3, just cancel this with this and you are remaining with root 3. So in the final answer, it's 4 root 3. It's the same thing. Okay. So this is how we solve it. And if you wanted the equation, I have done in steps. The tangent over here, this y naught value is done over here by substituting x naught value in this given equation. For wherever, if it's cosecant, just put 1 by sine. If it was cot, just put 1 by tan. That's it. And then m tangent, directly in calculator, you should put shift dy by dx and this thing and put the x value. You will get it. X naught will be given, y naught is found out. That's it. This is how easily we can solve this problem. And now we will move on to the next one. Okay, analysis of spring mass system. So here they have given real world problem. Suppose that u of t measures the displacement measured in inches of mass suspended from a spring t seconds after it is released, that ut equals 4 cos 2t. Find the velocity at any time t and determine the maximum velocity. Okay, maximum velocity. Now here you must always remember springs. What happens with springs and all? The motion is generally periodic, right? Like this, it might come. So this can be modeled in trigonometric function, cos or sine. Now here they have given you displacement. Do you remember derivative? If displacement is given as u of t, if you derive this, u dash of t is velocity. Okay, velocity. Now this is, we have done this in previous lessons, so please remember, when you derive displacement or position, you get velocity. So basically first step is to derive this. That's it. Let's derive it quickly. U dash of t equals, what happens over here, 4 is a constant, cos 2t will be minus sine 2t times 2. So you can just multiply this, it will be minus 8 sine 2t. So this is the derivative. This is basically the velocity. Okay, this is u dash of t or velocity. Let's just double check the answer. That's it. That's the velocity. Now what they want is maximum velocity. So you need to find the maximum oscillation, right? So we found that u dash is measured in inches per second. Now what is the range of this sine function? What is the range? You know the graph, right? What is the range of that graph? So it will be like this, 0, 1, 2. I mean, where does it go? If you recall, it's, you know, this line will be somewhere at 0 and this is 1, this will be minus 1. Okay, that's the range. So 1 and minus 1. Now, where will be the maximum, velocity? Is it over here or over here? Now, if you see this minus negative sign means, imagine this is the sine function. I'll just draw it over here. 1 second. Say this is the sine function, right? It starts from 0, goes up, comes down, goes up, okay, like this. But now when there is negative sign, it goes down first and then comes up and goes down. So what happens is the maximum velocity changes. So it's over here. I mean, what I mean to say is the maximum value will be when it's at minus 1. Okay, why? Because it changes. So the easy way to understand it, because I just got confused by it. The easy way to understand this would be, now substitute over here any one of the range. Which is the maximum value? Here, sine 2t, if you put minus 1, this entire thing, if you put minus 1, you'll get positive 8. Whereas if you put 1 over here, it will be minus 8. So minus 8 is lesser. Okay. So at this part, when sine 2t is minus 1, you get the maximum range, maximum positive value. Okay. So here, because there's minus sign, it flips. If it was plus, then obviously at 1, it would be maximum. At minus 1, it would be minimum. But since there's a negative sign already here, it is at minus 1, it's maximum. So the largest velocity that can be is at minus 8 times minus 1, that is 8 inches per second. Now when does this occur? When the sine 2t equals negative 1. That's what it's told. And now here, what time? Now you know sine 2t equals negative 1. This is the maximum velocity. U dash t means velocity, right? So at sine 2t, when it's minus 1, the range is minus 1, it's maximum velocity. But what is the time? Look at this function, just equate it. But let's solve this. What happens? Sine over here, take it to the other side, it will become uh, 2t equals sine inverse negative 1. Divide both the sides by 2. This is it. Find this value. You can use your calculator. All we need to do is put this value. Let's put this. Sine inverse of negative 1, close the bracket, divided by 2. It's negative pi by 4. This is a coterminal angle. We can take the positive angles. How do we take positive angles? Just add pi. Okay, yeah, pi. So add pi. It's 3/4. Okay, yeah, it's 3/4. 3 by 4 pi. Now, you know the period is 2 pi, right? Of this thing. So what you do is just add one more pi. You'll get, see, it's basically all these multiples because it keeps on repeating at pi. Sorry, here the period will be, the period is pi. See, period is given by 2 pi by b. Okay, so since b is 2, it will be at pi. So every pi it will start repeating. That means it comes to the same position at pi. So if you add one more pi here, what happens? It's 7 pi by 4 and so on. It keeps on repeating. Now even if you add one more pi to this, that is also an answer. Now if you find 1, it is enough. Don't use the negative angle, make it plus pi and you'll get the positive, and it keeps on repeating. So at all these times, so because the wave is something like this, it keeps on repeating the maximum at pi, pi, pi. So all these would be the answers. Even if you add pi over here, that is an answer. But you don't need all that. You can just write any one of this. If this is not there, this will be the answer. It's multiple of, you know, 3 pi, 3/4 pi plus pi again, you know, it'll be 1.75, 2.75 and so on. So these are the things. So that's basically it. So important things to remember this problem. Displacement is given, derive it, you'll get the velocity. Know the range, it's from -1 to +1. But here, since the negative sign, -1 would give the maximum velocity. Now, maximum velocity, that is sine 2t, equates -1, right? Now take the sine to the other side, it becomes sine inverse. How to remove this sign? Take sine inverse on both the sides. Then divide both the sides by 2, you will get, see, it's written over here, both the sides by 2, you'll get sine inverse of -1 by 2. That is the time, because this cancels. So time is, if you put in calculator, you will get -1/4 pi, add pi to it, you'll get 3 pi by 4. Or you can add pi's because the period is pi in this case. So that's it. So this is how you basically solve it. And that's the end of this lesson. I hope you have understood this. If you have any doubts, please do put them in the comments. I'll try to get back to you as soon as possible. Please remember, to know this lesson, you need to know the previous stuff as well. That is the previous 3 lessons: power rule, product rule, quotient rule, chain rule. So these are very important. Only then this will be easy. And also basics of trigonometry, what you have studied in grade 9 is crucial over here. Basic things of period and all that stuff, you know. So that will really help you understand this lesson thoroughly. And please memorize the formulas. All the formulas, they keep on adding. So please keep them in mind and then you can easily solve this. So that's it for this lesson. Take care guys and see you in the next video.